Scientific knowledge is the ability to do either good or bad, but it does not contain instructions for its application. To every man is given the key that opens the gates of heaven. The same key opens the gates of hell. Richard Feynman. Have you ever wondered why you are you and not someone else? Why are you living in this body and not the body of a Spartan you read about in a history book, or not the body of a man from the year 10,000? Perhaps it is a matter of pure chance. Even if such questions seem irrelevant or perplexing, they can still have practical implications. As strange as it may sound, your existence at this particular moment may give an indication of how long humanity has left before extinction. In 1983, theoretical physicist Brandon Carter presented a doomsday argument. Imagine you have two identical urns in front of you, one containing 10 balls numbered 1 to 10, and the other containing 1,000 balls numbered 1 to 1,000. You don't know which urn is which. Upon selecting an urn and pulling out a balloon, you discover that it is numbered 6. You are likely to conclude that you are more likely to draw a ball from an urn with 10 balls, since the probability of drawing a 6 in this case is higher than in an urn with 1,000 balls. Now, consider this. The total number of people who have ever lived is estimated to be about 100 billion. You are approximately the 100 billionth person on that list. This situation is akin to pulling a balloon numbered 100 billion out of an urn. Given that you are unlikely to have been born at the very beginning or end of human history, it is logical to assume that you are somewhere in the middle. If you are the 100 billionth person, that means that the total number of people who have ever lived in the past and future is likely to be around 200 billion. In this case, there is a 50% chance that you will be among the first 100 billion people, which seems plausible. However, if the total number of people in human history reaches 1 trillion, the probability of you appearing here and now is 10%. If there were 10 trillion humans, the probability of your existence at this early point in human history would drop to 1%. If we consider more speculative scenarios, such as space colonization and human presence on Earth for hundreds of billions of years, the probability of you being here and now is like pulling a ball from the very beginning out of an urn with sextillions of numbered balls. There are currently 8 billion people on Earth, and the Earth's population is larger now than at any time in history. Historically, for thousands of years, the Earth's population has been around 10 million people. Now, however, it has reached 8 billion. That's as much as 8% of all the people who have ever lived. And if there are only 200 billion people in all of history, we don't have much time left, given the rate of population growth. So, your current existence suggests that humanity has a limited amount of time left for a long history. Martin Rees, a distinguished British astrophysicist and cosmologist, argues that the chance of humanity facing extinction before 2100 is as likely as a coin toss, with odds of 50-50. His book, Our Final Century, delves into these risks. In many ways, the video is inspired by it. Rees' cautionary tale serves as a useful counterbalance to some of the overly optimistic books recently written by scientists. The Globe and Mail. The book was first published in 2003. I recommend reading it. The book is very relevant. You know, it's not just an end-of-the-world scare story. It's more of an admonition to mankind, and scientists first of all. We get used to everything new too quickly, and have very easily forgotten that the 21st century is an unprecedented century. There has never been anything even remotely like it in our history. Books about the end of the world have been appearing for centuries, but Rees' book is unique. And not just because of his fame as a Cambridge University professor who is not prone to making scary public statements. San Francisco Chronicle. Martin Rees says it is now, before it is too late, that we must realize our responsibility not only to humanity, not only to all living things on our planet, but even to all potential living things in our entire universe. One of the most provocative and disturbing books I have read in many years. That such a distinguished scientist as Rees voices such strong concerns is a sign that something is wrong. James Ballard, The Daily Mail. Also, as a source for this video, I can't help but mention an essay written by American computer theory scholar Bill Joy entitled, "Why the Future Doesn't Need Us." The essay, published in Wired magazine in 2000, sparked a global debate. Historically, natural threats to humanity, such as being preyed upon, contracting fatal diseases, or dying in volcanic eruptions, have either remained constant or decreased due to human efforts. However, the risk from a single type of hazard could multiply thousands of times this century. And now, a short commercial. After watching it, you will support my channel. Today, I want to share with you my experience working with the premium men's clothing brand, Fioboc. The brand sent me several items to test, and I was pleasantly surprised by their quality and attention to detail. In this video, we'll take a close look at each piece. I'll share my impressions and explain why Fioboc's clothing deserves your attention. First up, we have the Fioboc Weekend Performance Jogger. Now, these aren't your typical joggers. They're made with a high-performance fabric blend of 63% rayon, 30% nylon, and 7% spandex. What does that mean? It means these joggers are incredibly soft, stretchy, and durable. Whether you're lounging at home, running errands, or hitting the gym, these joggers keep up with your every move. I've worn them for a few days now, and they've quickly become my go-to for casual outings. The fit is spot on, snug where you want it but still breathable and comfortable. Another thing I love is the minimalist design. The clean lines and subtle details make these joggers versatile enough to pair with anything in your wardrobe. And the deep pockets. Game changer. No more worrying about your phone or wallet slipping out. Plus, they're machine washable and hold up great even after multiple washes. Next up, the Performance Pro Active Crew Neck Tee. This isn't just any tee. It's designed to be your go-to for both performance and style. Made from a blend of 88% polyester and 12% spandex, this tee is moisture-wicking, breathable, and quick-drying. Perfect for those intense workout sessions or just keeping cool on a hot day. I've taken it through some pretty rigorous tests, and it's held up brilliantly. No signs of wear and tear, and it still looks as fresh as the first day I wore it. The best part, the fit. It's designed to be athletic without being too tight, giving you that sleek look while still being comfortable. Whether you're at the gym or out for a casual day, this tee has got you covered. And trust me, once you put it on, you'll want one in every color. Last but certainly not least, we have the Stay Smooth long sleeve curve hem tee. This one is all about combining style with subtle sophistication. Made with 95% cotton and 5% spandex, it's soft, smooth, and has just the right amount of stretch. What really stands out to me is the curve hem design. It gives the shirt a modern edge, making it perfect for layering or wearing on its own. It's designed to keep you looking sharp all day long, with no worries about wrinkles or losing its shape. This is the kind of shirt that transitions effortlessly from a casual day out to a night on the town. And because it's so comfortable, you'll probably want to sleep in it too. In conclusion, I want to say that Fioboc is truly a brand worth your attention. Their clothing combines style, quality, and innovative materials. If you're looking for items that not only look great, but also last a long time, be sure to check out Fioboc. On their website, you'll find a wide range of clothing for various occasions, from everyday wear to formal events. I'll leave a link in the description so you can explore their products further. And with the promo code MW20 you will get 20% off. Einstein's famous equation, E=mc², illustrates how mass can be seen as frozen energy. In this equation, c represents the speed stands for the speed of light, and since it is a very large number, a tiny mass corresponds to a huge energy. Many people don't fully grasp the magnitude of this energy. On August 6, 1945, at approximately 8 a.m. local time, an atomic bomb detonated about 500 meters above Hiroshima, Japan. The explosion's heat was so intense that within a half-kilometer radius of the blast, temperatures reached those found on the sun's surface. Between 60,000 and 80,000 people died instantly. A well-known photograph shows the shadow of a man sitting on a step 260 meters from the blast's epicenter. The intense heat of the fireball imprinted his shadow on the surrounding rocks. This phenomenon is known as the shadows of Hiroshima. Many survivors suffered from long-term radiation sickness. The bomb, which weighed 4 tons and contained 64 kilograms of highly enriched uranium, caused devastation on a scale previously unimaginable. During the chain reaction of an atomic explosion, only 600 milligrams of the bomb's mass were converted into energy, less than the weight of a paperclip. This marked the first time humanity had access to a weapon capable of potentially annihilating our entire civilization in an instant. The advent of nuclear weapons introduced a new and unprecedented threat: the possibility of total nuclear war. President Kennedy himself said during the Cuban Missile Crisis that the probability of nuclear war was somewhere between 1 and 3 or even greater. The Cuban Missile Standoff in 1962 was the event that brought us closest to a deliberate exchange of nuclear strikes. According to historian Arthur Schlesinger, one of Kennedy's aides at the time, it was not only the most dangerous moment of the Cold War, it was the most dangerous moment in human history. Never before had 2 opposing powers possessed the technical capability to blow up the entire world. Imagine you are offered to play Russian roulette with 2 bullets out of 6 in the drum. How much money would it take for you to agree to play? Would you accept $1 million? $50 million? Most people would likely refuse any amount of money. This is akin to the situation during the Cuban Missile Crisis, where the risk of nuclear conflict was imposed on the world against its will. So was the threat of nuclear war ever fully resolved? After the bombings of Hiroshima and Nagasaki, the Bulletin of the Atomic Scientists was established by former members of the Manhattan Project. This journal, which focuses on international security and nuclear threats, is widely known for its Doomsday Clock. The clock's minute hand represents the metaphorical proximity of humanity to nuclear catastrophe. In its 75-year history, the Doomsday Clock has been adjusted 25 times. The clock is set based on assessments from experts, including 18 Nobel Prize winners. At the time the video is published, the hand is 90 seconds from midnight, closer than at any time in the project's history. The technology intended to protect us now holds the potential to annihilate us. While our advanced capabilities allow us to create power plants that provide energy and warmth, the same knowledge enables us to build weapons that threaten global destruction. And nuclear weapons are just one aspect of this dangerous potential. In his latest book, Short Answers to Big Questions, published at the end of 2018, Stephen Hawking writes in a separate paragraph, "The planet is now threatened in so many areas that I find it hard to remain positive. The dangers are too great and too numerous." This is the Arizona crater, also known as Meteor Crater, one of the most renowned craters on Earth. You may have seen it frequently in popular science shows. It's enormous. 12 soccer fields could fit across its diameter, and its depth is enough to stack 2 Statue of Liberties on top of each other. Many people mistakenly believe that this crater was caused by the same asteroid that wiped out the dinosaurs about 66 million years ago. However, that's not accurate. For starters, the asteroid did not kill all dinosaurs. Specifically, it didn't affect avian dinosaurs. When you eat chicken, you're actually consuming descendants of dinosaurs. Birds are not just related to dinosaurs. They are direct descendants from the theropod group, which includes the tyrannosaurs. Secondly, this massive crater in Arizona was formed by a meteorite only 50 meters in diameter. The stone that killed the dinosaurs was a block the size of Mount Everest, about 10 kilometers in diameter. It struck at an extremely steep angle and at a velocity of 72,000 kilometers per hour, 20 kilometers per second, which is 60 times the speed of sound. The impact would have been unimaginably powerful. For perspective, consider the eruption of Krakatoa, the loudest recorded event in human history. The explosion from the Krakatoa eruption was so intense that sailors 60 kilometers away had their eardrums burst, and the eruption's roar could be heard as far as Rodriguez Island, nearly 4,800 kilometers away. In comparison, the asteroid impact that caused the dinosaur extinction was 500,000 times more powerful. Even if the sailors had been on the opposite side of the Earth, their eardrums would likely have still been affected. Consider this: the most powerful bomb ever detonated, the hydrogen bomb, was nearly 3,500 times stronger than the Hiroshima bomb. Its mushroom cloud reached 67 kilometers high, and the explosion's flash was visible over 1,000 kilometers away. The blast wave traveled around the Earth 3 times. Now, multiply the effects of that explosion by 2 million. That's the scale of the asteroid impact. This level of devastation is beyond human comprehension. The deepest well ever drilled by humanity reaches just over 12 kilometers and took over 20 years to complete. In contrast, the asteroid impact created a crater 20 kilometers deep, instantly equivalent to stacking 24 Burj Khalifa skyscrapers on top of each other. The crater's diameter was an astonishing 180 kilometers, a distance that would take about 2 hours to drive by car on a highway. The impact caused catastrophic damage to Earth. You might wonder where this crater is and what it looks like now. It's located on the Yucatan Peninsula in Mexico. The place looks something like this. You wouldn't think it was the site of an event that wiped out 75% of the Earth's species. And really, 66 million years is a long time. The Earth, as a living system, has been gradually healing from the impact wounds inflicted by the asteroid that caused the dinosaur extinction. Today, the effects of this colossal event can only be detected with specialized equipment. The crater left by the meteorite is known as Chicxulub. For comparison, consider the Chelyabinsk meteorite, which was only 15 meters in diameter and weighed around 10,000 tons. Despite burning up and exploding in the atmosphere, a fragment weighing more than half a ton was recovered. One might wonder where the remnants of the massive asteroid that ended the age of dinosaurs are, considering it weighed about 1 trillion tons. The answer is that the remains of this ancient asteroid are indeed right beneath our feet. You can find them by digging down to the Cretaceous-Paleogene boundary in the rock layers. This boundary is present all around the world and is characterized by an unusually high concentration of iridium, a chemical element typically found in the Earth's core and mantle, but rarely present in sedimentary rocks. This iridium layer serves as evidence of the asteroid impact that changed Earth's history. And suddenly, there's a whole layer of it. That's why this phenomenon has been called the iridium anomaly. This iridium is believed to have originated from an asteroid, which, following a massive explosion, dispersed much of its mass across the planet. While most asteroids orbit safely between Mars and Jupiter, some follow paths that can intersect with Earth's orbit. These asteroids vary greatly in size, from tiny pebbles to small planets over 100 kilometers in diameter. Statistically, Earth is expected to experience a collision with a large asteroid every 50 to 100 million years. The Chicxulub impact 66 million years ago was not an isolated event. At one point, a much larger impact occurred on Earth, the Vredefort crater in South Africa, which is about 300 kilometers in diameter. The asteroid responsible for this crater is estimated to have been twice the size of the one that caused the extinction of the dinosaurs, measuring between 20 and 25 kilometers across. While Vredefort is considered the largest known crater on Earth, there are suspicions that Antarctica may hide an even larger one. Antarctica is not merely a sheet of ice floating on the ocean. It is a vast continent, which would look quite different without its ice cap. Gravity measurements by NASA satellites have suggested that there is an impact crater under the ice almost 500 kilometers in diameter. Currently, there is no data on the asteroid size that would have caused such a large crater, but a 2018 study proposes that it might have played a role in separating Australia from Antarctica. Any asteroid of that magnitude would pose a catastrophic threat to our civilization. With no effective defense against such large asteroids, Even early detection, several years in advance, would not prevent disaster. Fortunately, at present, there is no immediate threat of a large asteroid collision. However, such an event is inevitable at some point in the future. For instance, astronomers predict that the star Gliese 710 will pass within 1.3 million years at a distance of 1.5 trillion kilometers. Although this distance seems vast, it is relatively close in astronomical terms, being 25 times nearer than the closest star to the Sun currently. The gravitational influence of Gliese 710 will likely disturb comets in the outer reaches of the solar system, potentially leading to impacts on Earth. According to Martin Rees, projects like SpaceGORD could become a reality within the next 50 years. Such initiatives could help not only in warning us about potential asteroid threats, but also in protecting us from them. While these projects might not address the largest asteroids immediately, starting with smaller ones could still be beneficial. Even a 50-meter asteroid could pose significant problems, as exemplified by the Arizona crater. Astrophysicist and astronomer Carl Sagan, in his book Pale Blue Dot, highlights a troubling aspect of human nature: our tendency to underestimate the risks associated with new technologies or to ignore them altogether. In 1985, the Soviet Union's Deputy Minister for Nuclear Industry, speaking about the reliability of Soviet reactors, called Chernobyl an exceptionally safe place. The Deputy Minister assured that accidents at the Chernobyl site were expected to occur once every 100,000 years. However, it was discovered a year later that such an incident could actually happen 100,000 times more frequently. Similarly, contractors of the American agency NASA had projected that catastrophic shuttle failures would occur once every 10,000 years, but a year later, a shuttle exploded just 73 seconds after liftoff, resulting in the deaths of all 7 crew members. How about that? A seemingly minor miscalculation once nearly led to a global catastrophe. Chlorofluorocarbons, initially considered a safe and effective refrigerant in aerosol cans and household refrigerators, ended up creating a massive hole in the ozone layer. This unforeseen consequence was not anticipated by the chemists who developed them. These incidents illustrate that even well-intentioned innovations can have dangerously unexpected outcomes. These aren't isolated cases. The geological record reveals 5 major extinctions on Earth, representing enormous catastrophic events. We are currently experiencing a 6th extinction, which is unfolding on a scale comparable to these previous events. With the advent of Homo sapiens, species are going extinct 100 or even thousands of times faster than normal. Some species are disappearing as a direct result of human activity. Most extinctions, however, are the unintended result of human-caused habitat changes. As biologist Edward Wilson wrote in his book, Half-Earth, Our Planet's Fight for Life, the totality of life, known to scientists as the biosphere and to theologians as creation, is a wrap of organisms so thin that it cannot be seen from a space shuttle, yet so intrinsically complex that most of the species that make it up remain undiscovered. Many species on Earth have yet to be cataloged, and our actions are inadvertently causing their extinction. Despite our intelligence, we often exhibit significant recklessness. When it comes to asteroids, such carelessness could prove extremely costly. However, we must also consider another troubling scenario. In the winter and spring of 1945, Hitler ordered the destruction of Germany's infrastructure and basic means of survival because he believed that the surviving Germans had betrayed him and were inferior to those who had already died. Had Hitler possessed nuclear weapons, he likely would have used them without concern for retaliation. Now, consider a hypothetical technology capable of hurling massive stone objects into space. According to NASA, there are up to 1.9 million asteroids larger than 1 kilometer in diameter orbiting between Mars and Jupiter. This represents a staggering number of potential threats, about 1,000 times more than the stars visible to the naked eye under ideal conditions. An example of the potential danger is the impact event on Jupiter in 1994. A comet with a diameter of 1.5 to 2 kilometers, which had been fragmented by Jupiter's gravity, collided with the planet. The energy released by one of the fragments was estimated to be equivalent to 6 million megatons of TNT, hundreds of times greater than the total explosive power of all of Earth's nuclear weapons combined. This event demonstrated to even the most skeptical observers that cosmic collisions remain a real threat and that Earth could easily become a target. The U.S. Congress then funded the creation of a space tracking program, and on September 26, 2022, NASA for the first time tested a method of planetary protection by controlled collision of a spacecraft with an asteroid located at a distance of 11 million kilometers from Earth. It was a success, and as Carl Sagan asked, can we humans safely operate with technology that poses a threat to all civilization? Technology that could fall into the hands of a second Hitler, or just a technically incompetent or insufficiently cautious engineer. You can read about dozens of military nuclear accidents due to technical malfunction or completely careless handling of nuclear weapons. And that's just what is known to the general public. The risks far outweigh the benefits. The cure turns out to be scarier than the disease. Tracking asteroids and comets is sensible, good science that doesn't cost that much. But, conscious of our weaknesses, should we now, in principle, consider developing technology to deflect small celestial bodies? Carl Sagan. If someone decides to use such technology to secretly send a large asteroid to Earth, we are effectively doomed, because responding to such a threat requires an enormous amount of time. The response would require years of preparation, and by the time any sabotage was detected, it might be too late. Carl Sagan's point was that, in the short term, the risk of human-made catastrophes is statistically higher than that of natural events. Given this, colonizing other planets and star systems could be a viable strategy to mitigate such risks. Currently, no other planet in our solar system is as habitable as Earth, with Mars and Venus being notably less hospitable. Even with a collision from a 10-kilometer asteroid, Earth's conditions would likely still be better than those found on Mars or the gas giant moons. When it comes to exploring other star systems, the challenge is that we lack information about which might have habitable planets. Current methods, like sending individual space probes, are slow and costly. More efficient solution could be the von Neumann probe, named after physicist and mathematician John von Neumann, who developed the theoretical framework for self-replicating machines. The von Neumann probe is a completely unmanned spacecraft with artificial intelligence that can create copies of itself, just like many living things on our planet. For example, the marbled crayfish, which have spread globally from a single mutant individual, illustrate the principle behind von Neumann probes. These probes would function similarly. Upon reaching a new star system, they would utilize local resources to replicate themselves, with each new probe then continuing the process in other star systems. This exponential replication could eventually cover the entire galaxy. Current jet propulsion technology is adequate for this task. The probes would gather and transmit vast amounts of data back to Earth, helping us identify which star systems could potentially be colonized. The initial investment would be in just a few of these probes, which would then autonomously conduct exploration and replication. Interestingly, in some interpretations of Stanley Kubrick's 2001: A Space Odyssey, the monoliths are seen as a form of von Neumann probes. Additionally, the idea that extraterrestrial encounters might actually be with their von Neumann probes, rather than the aliens themselves, is supported by some scientists. In 1975, astrophysicist Michael Hart published a seminal study on the Fermi paradox, titled An Explanation for the Absence of Extraterrestrials on Earth. 6 years later, it was supplemented by cosmologist Frank Tipler in his article Extraterrestrial Intelligence Does Not Exist. Tipler argued that von Neumann probes, which are theoretically easy to create even for a relatively primitive civilization, could spread rapidly throughout the galaxy. Given that we have yet to detect such probes, Tipler concluded that extraterrestrial intelligence must not exist, and we are likely alone. This is the so-called Hart-Tipler hypothesis. However, Carl Sagan and William Neumann quickly challenged this hypothesis. They suggested that the absence of observed von Neumann probes might actually indicate the presence of intelligent civilizations. According to their view, no advanced civilization would build such probes, regardless of the potential benefits. Instead, they would likely destroy any alien von Neumann probes upon detection to prevent potential threats. Adding to the mystery, in 2017, astronomers observed an unusual object that came from interstellar space, beyond our solar system. This object was not noticed until it was close to Earth. Its shape was unlike any known object in the solar system, resembling a cylinder approximately 400 meters long and 40 meters wide. The intrigue continued in 2018 when a paper published in Nature reported that the object exhibited anomalous acceleration away from the Sun. The paper proposed 7 possible mechanisms for this acceleration, but none aligned with the observed data. This has further fueled speculation and interest in understanding the true nature of the object and its potential origins. It is indeed fascinating and quite intriguing. The object, initially proposed to be named Rama after Arthur Clarke's novel, was eventually named Oumuamua, which translates to scout or messenger in Hawaiian. This name reflects its potential as a visitor from beyond our solar system. The possibility of it being a von Neumann probe adds a whole new layer of speculation and excitement. Von Neumann probes represent a new form of life, not merely as unmanned spacecraft, but as highly advanced entities capable of autonomous operation. These probes could travel to distant star systems, land on planets or asteroids, extract and process materials, repair themselves, and reproduce, all without any external assistance. Their complexity includes strong artificial intelligence and functions similar to living organisms. Over time, these probes would experience evolutionary variability due to imperfections in the copying process. Just like biological organisms, each new generation of probes would accumulate errors in their replication instructions, leading to mutations. Many of these mutations would be detrimental, causing some probes to malfunction or become inoperative. However, some mutations might confer advantageous traits, leading to new properties and potentially giving rise to different species of probes. These probes, with their artificial intelligence, could develop varying personalities, compete in a Darwinian manner, and potentially form alliances or conflicts. As these probes evolve over thousands of generations, their behavior and characteristics could become increasingly unpredictable. The idea of meeting the descendants of an initially launched probe or encountering probes sent by an alien civilization introduces a range of uncertainties and potential risks. David Brin's 1983 article, The Great Silence, explores this issue by examining possible explanations for why we have not yet detected intelligent extraterrestrial life. The conclusion he reaches makes you shiver in your chair. According to his calculations, to the question, where are all the aliens? One of the most likely answers is killer space probes, or another name, the Berserker hypothesis. Brin's hypothesis suggests that for every large number of peaceful probes, there could be one or more civilizations that design their probes to be hostile. This idea raises the chilling possibility that the absence of detectable alien life might be due to the existence of such dangerous probes eliminating potential threats before they can communicate with us. As for us, we only invented radio about 130 years ago, and that's how negligible on a galaxy-wide scale the spread of our electromagnetic footprint looks since the radio era began. With our radio signals only having spread about 260 light-years from Earth, it's possible that more advanced or hostile probes, such as berserkers, haven't yet detected our signals or may be on their way. The concerns about the potential dangers of such probes are valid. If a civilization were to create self-replicating machines with advanced artificial intelligence, the risks are significant. The uncontrolled replication could lead to an overwhelming population of probes, akin to a cancerous growth, which would be extremely difficult to contain or manage. This potential for exponential growth poses a threat not just to the creators of these probes, but to entire star systems or even the galaxy. The warnings from experts like Stephen Hawking, Max Tegmark, Frank Wilczek, and Stuart Russell about the dangers of strong artificial intelligence underscore the seriousness of these concerns. They warned decades ago that the development of powerful artificial intelligence could be our last invention if not carefully managed, and emphasized the need for vigilant oversight and proactive measures to ensure that such technologies do not pose an existential threat. Especially when it's not just a few voices raising concerns, but numerous respected individuals as well. Right now, our civilization is accelerating towards creating artificial intelligence at the human level. Even if the warnings about potential dangers turn out to be unfounded and intelligent machines emerge without immediate negative consequences, it would still be problematic. This is because very few people have truly considered what it would mean to have another intelligent species coexisting with us, whether it's artificially created or extraterrestrial. We might convince ourselves that we're beyond primal instincts, but we have a natural aversion to entities that are different from us or that pose a threat. It's simply part of our nature. This applies even to non-intelligent species. Tigers might seem charming in controlled environments, but their danger becomes apparent in the wild. The challenge with artificial intelligence is that genuinely intelligent machines, however they are defined, won't just be tools we can control. They could be beyond our ability to manage and might not view us favorably either. Historically, when two intelligent species have existed simultaneously on Earth, it hasn't ended well for either. As for Oumuamua, it's highly unlikely to be a von Neumann probe. This peculiar object just passed through our solar system and is now moving away. Scientists are still uncertain about its true nature. Following the article in Nature, which proposed 7 possible explanations for Oumuamua's acceleration, none of which were satisfactory, new theories have emerged. These suggest that Oumuamua could either be extremely porous like a sponge, very thin like a sheet of aluminum foil, or some form of a thin, hollow shell. Despite these various theories, all of them seem far-fetched because there are no known natural objects in space that resemble Oumuamua. As a result, astronomers decided to search for similar objects within our solar system. They discovered something with comparable properties, an empty rocket booster from a 1966 NASA mission, featuring very thin stainless steel walls. This is quite intriguing and suggests that Oumuamua is definitely not from our solar system. If it turns out that this space debris is actually evidence of an alien civilization, it would require a major reevaluation of our understanding of how to live our lives. Oumuamua represents the only observed object that hints at a potential extraterrestrial artificial origin, rather than providing direct proof. Arthur Clarke famously said, "There are 2 possibilities. Either we are alone in the universe, or we are not. Both are equally terrifying." Any potential contact with extraterrestrial intelligence would be the most unpredictable event in human history. Therefore, it would be wise to thoroughly investigate Oumuamua, the first known messenger from beyond, to understand what it truly represents. The Lyra project, in partnership with NASA, is exploring the possibility of sending a spacecraft to Oumuamua. Although catching up with it may take several decades at best, it's certainly worth the effort. So it might be wise to consider a healthier lifestyle to ensure you'll be around to witness this event. Regarding life extension technologies, it's worth noting that they can indeed be dangerously complex. The danger isn't primarily about overpopulation, but rather the implications of extending human life. One approach to combating natural death is genetic editing, a topic I've covered extensively in 2-hour-long videos. However, let's explore a different method for extending life. In 1959, physicist Richard Feynman delivered a seminal lecture at the California Institute of Technology titled "There's Plenty of Room at the Bottom," which inspired a generation of researchers. Feynman proposed the possibility of building a machine capable of manipulating individual atoms and molecules. He suggested creating a manipulator as small as possible and programming it to produce a smaller copy of itself. This process would continue, producing increasingly smaller versions until a manipulator could operate at the scale of individual atoms. This lecture marked the beginning of nanotechnology, which was later popularized by engineer and scientist Kim Eric Drexler, often considered the father of the field. Drexler, along with artificial intelligence scientist Marvin Lee Minsky, discussed these concepts in their book Engines of Creation: The Coming Era of Nanotechnology. They envisioned nanomachines capable of repairing bodily damage, potentially preventing aging. Aging is commonly understood as the process through which damage accumulates within the cells of the body over time. According to the prevailing scientific hypothesis, this accumulation of damage leads to the gradual decline in the function and efficiency of bodily systems. Aging is viewed by many scientists as a type of physical disorder, and in some circles is even proposed to be classified as a disease. Kim Eric Drexler notes that scientists have a clear understanding of the principles that will enable molecular machines to function. With this knowledge, the concept of achieving eternal youth could potentially be incorporated into future plans. Medical research is leading us step by step on the road to molecular machines. Global competition for better materials, electronics, and biochemical tools is pushing us in the same direction. The development of cell repair machines will take years, but the path is straight, and they are waiting for us at the end of it. Eric Drexler. It might sound like science fiction, but actually, these robotic assemblers that Drexler calls nanoassemblers actually already exist, and they exist in every cell in our bodies. They are ribosomes, ranging from 25 to 30 nanometers in diameter. Ribosomes build proteins atom by atom according to instructions from RNA, essentially creating our flesh and blood. These biological machines assemble proteins with incredible precision and versatility. If you've ever seen animations depicting subcellular processes, the idea of creating artificial nanorobots might seem quite plausible. Artificial nanoassemblers would perform tasks similar to ribosomes, but with the added capability of potentially creating new forms of matter or repairing tissues in ways natural systems can't. As Eric Drexler suggests, people who use cell repair machines could potentially regain and maintain their youthful health for extended periods. However, the challenge lies in the fact that a single nanoassembler is not particularly useful. We would need trillions of them. To achieve this, these machines would need to replicate themselves many times over. This introduces significant risks, akin to those posed by von Neumann probes. Drexler warns that the process of self-replication in nanoassemblers is fraught with danger, as it could lead to uncontrollable replication and potentially catastrophic consequences. Essentially, we would be creating a new form of life with all the associated risks. The dangers of nanoassemblers could become apparent almost immediately after their creation, unlike the more gradual risks associated with von Neumann probes. Here's a look at the calculation Drexler cites. Imagine a similar replicator floating in a bottle of chemicals making its own copies. The first replicator assembles its copy in 1,000 seconds. Then 2 replicators assemble 2 more in the next 1,000 seconds. Now 4 replicators build 4 more, and 8 replicators build 8 more. After 10 hours, there are no longer 36, but over 68 billion. In less than a day, they will have gained a ton of weight. In less than 2 days, they will weigh more than the Earth. And in another 4 hours, their weight will exceed the mass of the Sun and all the planets combined, unless the chemical bottle is emptied long before then. Indeed, while the scenario of a sudden catastrophic event might seem extreme, Drexler's work highlights the potential risks associated with exponential growth in nanotechnology. In reality, the danger might not come from an immediate disaster, but from a gradual and uncontrolled spread. A single mistake in the self-replication process could trigger a cascade of exponential growth. Nanomachines could potentially be engineered to consume a wide range of materials, possibly even all organic matter. This raises the question of how to prevent them from consuming everything, including us. If these machines spread and multiply uncontrollably, they could begin to consume the biosphere. turning it into dust in a scenario Drexler termed the gray slime scenario. The name gray slime reflects the idea that these replicators, while highly successful in evolutionary terms, would ultimately be less interesting compared to the diversity and richness of natural life. Replicators may be more effective than nuclear weapons. To devastate the Earth with bombs would require masses of exotic hardware and rare isotopes, but to destroy all life with replicators would require only a single speck composed of ordinary elements. Eric Drexler. This is called ecophagy. The term was coined by Robert Freitas Jr., an American nanotechnology expert, in his great article entitled Some Limits to Global Ecophagy to Biovirus Nanoreplicators. With public policy recommendations, he provides calculations of the rate of destruction of the biosphere by such replicators. So, it could take anywhere from just under 3 hours to 20 months or more, depending on the scenario. He ends with specific recommendations to policymakers, the first of which is an immediate international moratorium on all experiments with artificial life. You might say, why don't we just use some kind of defense system? Drexler himself writes in the book that we should build an active nanotechnological shield, something analogous to an immune system, to protect us from dangerous replicators of all kinds that could, by human error or intent, slip out of the labs. But there is one huge problem here, which has been written about in detail by computer systems theory scientist Bill Joy in his article entitled, Why the Future Doesn't Need Us. On March 23, 1983, U.S. President Ronald Reagan announced a program called the Strategic Defense Initiative, whose mission was to create a shield for America against Soviet nuclear missiles, not just to respond to nuclear aggression with nuclear aggression, but to destroy all Soviet ballistic missiles fired. There was something about destroying Soviet missiles with lasers from space from satellites. That's why this program was popularly called Star Wars. Arthur Clarke, who was a consultant in discussing this project, noted, I suspect that full defense might indeed be possible in a century or so, but the technology involved would produce, as a byproduct, weapons so terrible that everyone would forget about something as primitive as nuclear missiles. An immune system against dangerous replicators would itself be extremely dangerous. To use a human analogy, there is a whole list of deadly diseases in which we are attacked by our own immune system. These are so-called autoimmune diseases, and nothing will prevent the nanoreplicator shield from developing autoimmune mechanisms and attacking the biosphere itself directly. These technologies are too powerful to be limited within the scope of current interests. Even if a defense of this type were possible, the side effects of developing such a technology would be at least as dangerous as the very technologies we are trying to defend against. Thus, all of these possibilities are either undesirable or unattainable, or both. The only real alternative, it seems to me, is retreat. We need to limit the development of technologies that are too dangerous by limiting our pursuit of certain kinds of knowledge. Bill Joy. Almost any powerful technology has the potential to cause harm, whether intentionally or unintentionally. The possibilities for misuse are vast. Take teleportation, for instance. An incredibly useful technology straight out of science fiction. It doesn't take much imagination to see how it could be used in frightening ways. So, do we really need immortality if it comes with the risk of potentially destroying all life on Earth? Is it worth pursuing, given the possible dangers? And how close are we to realizing nanoreplicator technology? Consider the development of the first nuclear bomb, which cost approximately $35 billion, adjusted for inflation, and required the combined efforts of the brightest minds of the time, plus an additional 130,000 people working over 5 years. Did the average American know about this effort? No. One day, they simply woke up to the shocking news that bombs capable of obliterating entire cities were now a reality. Later on, it became clear that the Soviet Union also possessed such bombs, and their stockpile was growing uncontrollably. Often, the general public remains unaware of many significant developments until the last possible moment. We suddenly discover new features on our phones, like pinch to zoom, or marvel at images of black holes, or hear artificial voice assistants perform duets. We rarely know the critical mass of technological innovation that leads to these advancements. We don't track it and generally remain in the dark about it. It's unlikely that any single country has exclusively invested its resources into developing nanobots. Unlike nuclear weapons, nanotechnology is seldom discussed in the context of weaponry. Therefore, private companies might also be working on such developments. The question remains, is anyone keeping track of these developments? At what point will we find ourselves in a world where technology allows us to build such advanced machines? We already have our first robot favorites, as well as genetically engineered techniques available for purchase, and our nanoscale technology is rapidly advancing. While the development of these technologies goes through many steps, the last step in testing a technology is not necessarily a big and difficult one, as happened in the Manhattan Project and the Trinity Trial. Breakthrough to wild self-replication in robotics, genetic engineering, or nanotechnology could come suddenly, causing the same kind of surprise we experienced when we learned about mammalian cloning. Bill Joy. In 2004, then Prince Charles of Great Britain requested that the Royal Society of London examine the risks associated with grey goo and produce a report. The Society's report, published on July 29, 2004, argued that the possibility of self-replicating machines was still too far off, and therefore should not attract the attention of science and technology regulators. Eric Drexler, who initially raised the grey goo scenario, later acknowledged the risks as unlikely and regretted coining the term due to the resulting hype. However, should we dismiss such a scenario solely because of its low probability? During World War II, some scientists involved in the development of the nuclear bomb feared that an explosion might ignite a chain reaction capable of setting the atmosphere and oceans on fire, though initial calculations suggested the probability was only 3 chances in a million. We now know that nuclear weapons, despite their destructiveness, cannot achieve this. Today, however, some physical experiments conducted purely for scientific purposes, without involving weapons of mass destruction, are still suspected of posing potential global or even cosmic threats. Do you remember this video, where after the launch of the Large Hadron Collider, a small black hole appears due to the high energy of proton collision and begins to gradually absorb the entire Earth? There were fears that the high-energy proton collisions could potentially create a small black hole that might gradually consume the entire Earth. Although such a scenario was deemed highly unlikely by scientists, it highlighted the uncertainty surrounding the creation of extreme physical conditions in the Large Hadron Collider. The Earth is indeed a unique environment for such experiments, as the conditions scientists create in particle colliders, like extremely high energies, pressures, and temperatures, are not typically found elsewhere in the observable universe. Physicists push the boundaries of these extremes to explore fundamental questions about the nature of the universe, which is why they build complex machines like particle accelerators. These devices accelerate subatomic particles such as protons to nearly the speed of light and collide them to achieve immense concentrations of energy. And, as Martin Rees writes, some physicists allow for the possibility that these experiments could lead to something far worse than the destruction of a few atoms, such as the destruction of our Earth or even our entire universe. An experiment that generates an unprecedented concentration of energy could, presumably, but highly improbably, trigger 3 very different disaster scenarios. The first is indeed the emergence of a black hole, but this hole would be very small and, because of Hawking's radiation, would instantly vaporize without causing any damage. The second alarming possibility involves quarks, the fundamental particles of matter, aggregating into a highly compressed entity called a strangelet particle. Although this particle would be much smaller than an atom, it could pose a risk if it began to interact with surrounding matter, converting it into similar strangelet particles. This hypothetical scenario could eventually transform the entire Earth into a superdense sphere roughly 100 meters in diameter. The third risk, which is even more exotic and potentially catastrophic, involves the nature of empty space, or the vacuum. Far from being mere emptiness, The vacuum is a dynamic medium that supports all physical forces and particles. Some physicists theorize that space might exist in different phases, akin to how water can be liquid, solid, or gaseous. Moreover, the state that space is in now, it may be very fragile and unstable. Again, the analogy with water: if you put distilled water in the freezer overnight and carefully take it out in the morning, it will still be in a liquid state. But this liquid state is unstable, and if a speck of dust gets into this water, or if you accidentally knock the bottle, the water will instantly begin to turn to ice. The transition of water from one state to another, such as from liquid to ice, is called a phase transition. And some scientists hypothesize that the concentrated energy from the collision of particles could cause space to undergo a similar phase transition, and this transition would tear the very fabric of space. The deadly boundary would spread like an expanding bubble. It would be impossible for atoms to exist in that bubble. So that would be the end for us and for the entire observable universe, and we wouldn't even know we were dead. It would be impossible to see the approaching bubble. It would expand at the speed of light. These scenarios may seem bizarre, but physicists discuss them with a nonchalant face. The most popular theories are reassuring. They imply that the risk is zero, but we can't be 100% sure of what will actually happen. Physicists can come up with alternative theories and even write down equations that are consistent with everything we know, and therefore cannot be absolutely ruled out. But which would allow one or another of these catastrophes to happen? These alternative theories may not be in the lead, but are they all so improbable that we shouldn't worry? Martin Rees. As Martin Rees notes, while one might argue that the likelihood of negative outcomes is low, when physicists explore events or processes that are unprecedented or poorly understood, their estimates are often just educated guesses, which could prove incorrect. Dr. Peter Michelson from Stanford University once cooled a gravitational wave detector, a massive metal rod, to near absolute zero, making it the coldest large object in the universe. In science labs, temperatures close to absolute zero are achieved using liquid helium, but such conditions are not naturally found on Earth or elsewhere in the universe. Space itself is only slightly warmer, about 3 degrees above absolute zero, due to microwave background radiation from the Big Bang. This raises the question: should there have been concern when the first liquid helium refrigerator was activated? Martin Rees says it actually was. Going back to colliders, particles do collide with much higher energies in space, but the conditions there are still different from the conditions in colliders. In any case, these scenarios are really extremely unlikely. The largest collider in existence has been running for years, and all is well. However, Martin Rees asks the question: what risks will be acceptable? The Brookhaven report and parallel work by scientists at Europe's largest gas pedal, CERN in Geneva, have been presented as encouraging. However, even if one fully accepted their reasoning, the level of certainty they offered hardly seemed sufficient. They calculated that if the experiment were conducted for 10 years, the risk of catastrophe would be no more than 1 in 50 million. These odds may seem encouraging. The chance of catastrophe is less than the chance of winning the UK National Lottery on a single ticket, which is about 1 in 14 million. However, if the downside is the destruction of the world's population, and the benefit goes only to pure science, it is not enough. Martin Rees. Although it is a debatable philosophical question, we are not just talking about the 8 billion people that currently exist. We are also talking about the people that will never be born in the event of a catastrophe. New collider, costing over $20 billion, and set to be several times larger than the Large Hadron Collider, is planned to be operational by 2040. French mathematician and philosopher Blaise Pascal famously argued that one should act as though God exists, even if one does not believe in him. Pascal's reasoning was that, while the probability of God's existence might be very small, it cannot be zero. So what then do you risk if you believe in God, but it turns out in the end that he doesn't exist? Well, it will turn out that you have performed rites, fasted, and led a righteous way of life in vain. You will not get any reward for it. However, what do you risk if you don't believe in God and He suddenly exists? In that case, your risks are monstrous. After death, you will burn in hell for eternity. Thus, from Pascal's perspective, it is rational to believe in God to avoid such catastrophic risks. While this argument might seem strange, especially as it presumes a particular outcome of divine judgment, it underscores the idea of making cautious decisions in the face of uncertain, potentially high-stakes risks. When a potentially catastrophic downside is possible, not just in gas pedal experiments, but in genetics, robotics, and nanotechnology, can scientists provide the ultra-reliable safeguards that the public might demand? As the power of science grows, I believe such risks will become more diverse and widespread. Even if each risk is small, they can grow into a significant cumulative hazard. Martin Rees. Martin Rees' message is not about predicting imminent doom or halting all scientific research. Instead, he emphasizes the need to recognize and manage the responsibility that comes with today's scientific advancements. As Franz Kafka observed, precaution requires living with the risk of life. The risks associated with science can be a necessary part of progress, and avoiding all risks might mean missing out on significant rewards. Rees suggests that the responsibility we bear now is vastly greater than ever before in human history. The end-of-the-world argument, initially put forth by Rees' colleague Brandon Carter, is not merely a rhetorical device but has impacted how some view humanity's future. This perspective leads to debates about whether global decisions such as investing in space colonization programs should be guided by such arguments. After all, if these programs were successful in the future and space ended up being populated by trillions of people, you would be unlikely to be on the human roll so early. And consequently, these programs would most likely fail. There is one big but here, however, called the reference class problem. Perhaps the end-of-the-world argument is not an end-of-the-world argument, but tells us something else. Many people imagine the settlement of other planets as the colonization of space by humans, but this is not the case. If we were able to start gradually spreading human colonies throughout the galaxy, and this continued for hundreds of thousands of years, the colonists would not be human when they reached the edge of the galaxy. Moreover, by then there would probably be no humans left on Earth either. Charles Darwin observed that no species remains unchanged indefinitely. Over time, species evolve. As human colonies spread and adapt to diverse planetary conditions, they could give rise to a vast array of new species. Additionally, rapid changes might occur through genetic modifications or integration with technology, leading to post-human descendants that might be quite different from today's humans. The end-of-the-world argument might not necessarily imply the extinction of humanity, but rather the transformation of humanity into forms that are unrecognizable compared to what we consider human today. Thus, the real question might be less about whether humans will go extinct, and more about how our species will evolve and transform in the future. If humanity evolves into vastly different forms, or even entirely new species as it spreads across the galaxy, it's no surprise that you are here and now. The sheer enormity of future populations doesn't diminish the significance of our current existence. The future of humanity is complex and cannot be reduced to a mere mathematical model. The comparison with the early aquatic creatures that first ventured onto land over 300 million years ago underscores this point. Those early creatures, seemingly unremarkable compared to today's diverse terrestrial life, played a crucial role in the development of the rich and complex biosphere we see now. Without their survival and evolution, much of the life we know would never have existed. Similarly, the potential of post-human forms is vast and largely unknown. If we are indeed alone in the observable universe, then our present moment holds immense significance. The future is full of potential, but the present moment and the choices we make now are crucial for shaping that future. However, look at this picture. Do you see anything in it? It's a picture of the Earth against the backdrop of the universe, taken by the Voyager 1 space probe from the edge of the solar system. The idea to capture the Earth from this distance was Carl Sagan's. After seeing this photograph, He was so impressed that he later wrote the book I mentioned earlier today. Sagan called the book Pale Blue Dot. From so far away, the Earth may seem insignificant, but to us it is special. Look at this speck. Right here. This is our home. This is us. Everyone you know, everyone you love, everyone you've heard of, every human being who has ever existed in the world has spent their lives here. The sum of all our joys and sufferings, thousands of established religions, ideologies and economic doctrines, all hunters and gatherers, heroes and cowards, creators and destroyers of civilization, all kings and peasants, couples in love, mothers and fathers, hopeful children, inventors and explorers, moral authorities and unscrupulous politicians, all the superstars and great leaders, all the saints and sinners in the history of our species have lived here, on a speck of dust suspended in a beam of light. Our planet is a lonely speck in the great all-encompassing cosmic darkness. We are lost in this vast void, and there is not even a hint that help will come from somewhere, and someone will save us from ourselves. So far, Earth is the only inhabited world we know of. We don't know of any other place our species could move to, at least not in the near future. To visit, yes. Settle, for now, no. Whether we like it or not, Earth is the only place that can take us now. They say that practicing astronomy builds humility and character. Perhaps nothing demonstrates the frailty of human whimsy more than this distant image of a tiny world. In my opinion, it emphasizes the responsibility we have to treat each other more humanly, and how we must preserve and protect this little blue spot, the only home we know. Thank you for watching. Special thanks to sponsors. If you want to support my channel, put a like and subscribe.